Okay, so this is the question 9 from November 2018. The electrolytic cell below is set up to obtain pure copper from a piece of impure copper. The impure copper contains other metals such as platinum, iron, cobalt, silver, and nickel. It says the cell potential of the power source is adjusted so that only copper is deposited on electrode B. Okay, so only copper is deposited here. Define an electrolytic cell. Well, this is kind of like part of your electrolysis definition. So an electrolytic cell is a cell in which electrical energy, because they're always interested in the energy conversions, in which electrical energy is converted. Goodness me, look at my handwriting. What is electrical energy converted to? Electrical energy is converted to chemical energy. Okay, remember, also you could say something along the lines of electrical energy is used to provide energy to a chemical reaction to produce a chemical product that you want, but it's easier just to say electrical energy is converted to chemical energy. Now it says write down the formula of a suitable electrolyte for this cell. So this electrolyte is the liquid that's running around in here. We need something that contains copper ions. So my first go-to solution is copper sulfate because that's readily and easily available. But you could also use copper chloride, or you could use copper nitrate, so long as it is a soluble copper salt. And copper sulfate is just the easiest one that springs to mind. Okay, now it says which electrode, A or B, is the cathode. Write down the relevant half reaction taking place at this electrode. Now remember, I always tell you, oil rig, red cat. Reduction occurs at the cathode. What is reduction? Reduction is gain of electrons. So I need something to gain electrons. So what will gain electrons here? Copper ions will gain electrons and go to copper metal, because that's what we want to do. We want something to gain electrons. So now if you put this reaction the wrong way round, you are going to get no marks. You have to have the reduction reaction, and reduction is gain of electrons. The only thing in here, we've got copper metal and copper ions. The only thing that can gain electrons are the copper ions. So it has to be going in this direction. Copper 2 plus 2 electrons goes to copper metal. So this is the half reaction. It's balanced. Remember your charge on your ion and your charge on your electrons. Now it says to you, sludge forms below one of the electrodes while the cell is in operation. Which of the metals, platinum, iron, cobalt, silver, or nickel, will be present in the sludge? Now, if I just looked at this question and I knew nothing and I saw 2 marks, I would suspect I'm going to have either 1 metal for 2 marks or 2 metals for 1 mark each. So if we go look, how would we figure this out? Okay, here is a reaction, copper 2 plus going to copper metal. So what we do is we go to our table of standard electrode potentials and we look for copper 2 plus going to copper metal. Can you see it over here? Okay, and then it says to you platinum, iron, cobalt, silver, and nickel. So we look for the rest of them. Start at the top here, start at the top here. Look, here is platinum. Okay, then it says iron, cobalt, silver, or nickel. So let's look for any of them. Look, here is silver. Remember, silver is Ag, argentium. Okay, so here's silver. Then it says iron. Okay, but this is an iron. It's not iron metal. So here is our first reaction where an iron is going to iron metal. Here is another reaction of iron going to iron metal. Where is cobalt? Here is cobalt. And what else are we short of? What have we not found? Nickel. Here was nickel up here. So here is the reaction that is occurring. So they've set this cell to make this reaction over here. So We want copper ions going to copper metal. Which one goes easiest to copper metal, or I mean to a metal here? Everything above here will easily have the forward reaction be favored, because look, the E theta is positive. This is a positive. This is a positive for the forward reaction. These are all negative. They will not want to occur. So I'm most likely to get platinum and silver out of the cell, because the rest of them have all got a negative E theta for the forward reaction. So the answer to this one will be platinum and silver. So if you had to answer the question, you would say that platinum and silver are actually more easily reduced than the copper ions, but the rest of them, iron, cobalt, and nickel, are harder to reduce. So they do not, they stay as ions, they do not come out as metal.